classes. So should I start, everyone? Yes, ready for the classes? That's great. Now, so today will be the last class on the chapter Matter Around Us. Okay? Yes or no? So in today's session, we are going to do one short session. Or do you understand what is one short session? No, we are going to revise all the topics, all the questions, all the types of questions in just one session. Okay, so this session will be little bit quick. Okay, everyone, because we have discussed each and every topics in detail in previous sessions, right? So today we are going to revise all the topics. So are you all ready for this? Yes, and in case of any doubt, suppose you're having any kinds of doubt in any other topics, just raise your hand, and at that time only we are going to revise that particular topic. Okay? Okay, that's great. So we all have studied all these topics, yes or no? Yes. Is there any topic left from these mentioned topics? No? Sure? Yes. That's great. Now, in the last session, what we discussed about the diffusion, we discussed about the important points like sublimation, evaporation, cooling effect, yes or no? Yeah, and we have seen some of the examples of the diffusions in gases, liquids, and solids, yes? And today we are going to revise, and revise. Okay. So let's start. Yes or no? Yes. Not getting voice. Yes or no? Yes. That's great. That's great. So first of all, before going directly into the topic, today I am going to ask you the questions and you are going to explain me the topics. Correct? Okay, so who is going to explain about the matter? That what is matter? Just raise your hand once. Who wants to explain this to the whole class? It's a very easy question, right? What is matter? Yes, please come in front. Yeah.
Matter is anything that occupies space and mass.
Yes, it's a very good definition. Yes or no? Any doubts in this definition, guys? No? Yes, please sit down. Clap for her. So, like, we all know the definition of matter. Yes or no?
Yes.
So, everyone just, I'll count 1, 2, 3, and then you're going to tell me the definition of matter, okay? 1, 2, and 3. Please say. Yes, so there is no confusion in the definition of matter. Yes or no?
Yes, sir.
Okay, so should I move forward?
Yes, sir.
That's great. So let's check now. Have I written the definition correctly here? Can you just check it? Is it correct? Yes. And there's so many examples of the matter, right? We have the iron, we have water. Water can be considered as matter, yes or no? We have oxygen, we have air, yes or no? All these things are the matters. Now, anyone who is going to give me an example of non-matter?
Shadow, sir.
Shadow, exactly. Any other examples? School 1, school 2, anyone?
Emotions, sir.
Emotions, exactly. Yes. So I believe that the concept of matter and non-matter is clear to each and every one of you. Yes or no?
Yes, sir.
Clear? Should we move forward?
Yes, sir.
No doubts in this section?
No, sir.
That's great. Now, okay, how many states did we study?
3 stations.
3 or 5?
5, sir.
5 states. And what are the major 3 states?
Solid,
Yes. And in addition, we have two extra states, that is plasma and the, yes, I have forgotten what was the name of the fifth state. Everyone has forgotten. Yes, I'm able to hear someone is whispering, boss, boss. Now they're opening the notebooks. So what was the name of the fifth state? Yes, someone is trying to say. You can come in front and speak. Yes, it was Bose-Einstein. Remember? Yes. Yeah. So how many states of matter do we have? We have basically, if I talk about main states of matter, so we have three states of matter, that is solid, liquid, and gas. And in addition, we have two more states of matter, which is known as plasma and what? And Bose-Einstein. Remember? Okay. Clear to everyone? Okay. Now, I am going to ask some of the questions, then we are going to revise it completely. Will that be okay? Okay. If suppose I am going to ask anyone, look, I'll choose the students. Whom should I choose? Okay, in the school one, the boy who is sitting just below that bulb. Yeah. Can you just stand up? Just below that bulb. Yeah. Yes, please stand up. I'm going to ask you a question. Not a very difficult question, just a normal question. Can you please come forward? Yes. Tell him to come forward. Yes, please stand up. Yeah. School one. Yes. Oh, am I? Okay. Yes, you can just stand at your place. Yes, please stand up. Yes, you. Stand up fast. Yes, stand up. Please stand up. Okay, come forward. Come forward. That's great. So I'm going to ask you one question. Should I ask you a very easy question or a very hard question? Guys, what do you say? Easy question or a hard question?
Easy, sir.
Easy. Okay. So name any three properties of solid state. It's a very easy question, right? Yes. Any three properties of solid state? Solids are? I can see school 2 girls are just, let's see whether the sir is going to ask same questions from me too or not. Yes, please answer. Any three properties of solid state? Any three. Okay, do you need any kind of help from my side? Should I help you in the answering this question?
Yes, sir.
Okay, chalo. So solids have fixed volume, fixed shape or not?
Yes, sir.
So this is the properties of solid, yes or no?
Yes, sir.
Okay. Can solid be compressed? Can solid particles be compressed?
Yes, sir.
So this is one of the property of solid, yes or no? So that's what you have to answer, right? Clear?
Yes, sir.
Okay. Please go back to your place. Now, everyone repeat after me. There are some properties of the solids which I'm going to show you just in the next screen, and you are going to check these properties. Okay. And I'm going to ask you about these properties. I'm going to give you 2 minutes to go through this table, and then I'm going to ask you the question. Ready, everyone?
Yes, sir.
Okay, chal. So start reading from here. If I talk about the solids, so what about the interatomic spaces of the solid? the atomic spaces in the solids are very less, very more, or maximum? Very less, yes. In liquid, the interatomic space or the intermolecular space is more than liquid, but less than gas. Yes or no?
Yes, sir.
And in gases, the particles are very far from each other. Yes or no?
Yes, sir.
Clear? Okay. Now, what about the shape? Solid have fixed shape, liquid do not have fixed shape, and gases also do not have fixed shape. Yes or no?
Yes, sir.
What about the volume? Yes, solids have the fixed volume, liquids also have the fixed volume, and the gases do not have fixed volume. Yes or no?
Yes, sir.
That's great. This was school 1 or school 2? School 1? Who said yes, said right now? School 1 or school 2? School 2. Okay, that's great. Now, compressible. Obviously, solid cannot be compressed. Yes or no? Can you compress the solid? But we remembered one exception. Do you remember that exception? There was one solid which can be compressed. Yes, exactly. So you have to remember that this is a kind of exception. Like here, there is one solid which is known as sponge. It can be compressed. Yes or no?
Yes, sir.
Okay. And ability to flow, like the solids can flow or not? Can solids flow?
No.
No. But liquids and gases can
No.
flow. So now I think so, you all are able to, relate the things which we studied in the previous classes. So should I ask you the questions? Okay. Rather than asking questions, who is going to explain me the properties of liquid? Anyone? Fast, school 1, school 2. Who is going to explain me the properties of liquid? Not all, just whatever you remember, you are able to remember that on. Anyone? School 2? School 2, school 1? Yes, please come forward. In the holidays, you have forgotten everything. Oh. Okay, should I choose? Should I choose the students?
Yes,
Okay. The girl who is sitting in first, second, third bench, school 2. Sorry, yeah, third seat, school 2. Yes, you. Yes, yes. Okay. What's your name?
My name is Divya, sir.
That's great. How are you? Fine, now? You enjoyed your holidays?
Yes, sir.
Okay. Now, you can just explain us the properties of the liquid. I'm seeing those two girls sitting beside you. Are they helping you? No? Okay, that's great. Okay. Let's tell me the properties of the liquid. Properties can flow or not? Sorry, liquid can flow or not?
Yes,
Okay. What are the other properties of liquids? What about the distance between the molecules of the liquid? Is it more or is it less?
yes, sir.
Less. Okay. And what about the, can we compress the liquid? Can we compress the liquid?
Yes, sir.
Okay. Yes, everyone, do you agree with the answer? Can we compress the liquid? School 1, school 2?
Yes, sir.
Yes, exactly. We can compress the liquids. Okay. Chalo, that's good. Sit down. Okay. Clap for her, guys. Okay. Now, anyone who wants to explain the properties of gases? Anyone? Okay. From school 1, the girl sitting in the second bench, middle one. Second bench, middle one. Yes, please stand up. Okay. You can come in front. Yeah. Okay. So I'm just going to ask you about the properties of gases. Can you explain us? Let's start with the compressibility. Is gas compressible or not?
Yes, sir.
Okay. And what about the space, intermolecular spaces? Is it very less, very medium, or it's very large?
Large, sir.
Largest, exactly. And what about like can gases flow? Like fluid is present in gases or not?
Yes, sir.
It's present. That's great. So this is all you have to write. If suppose in case in your exams it is being asked, write the properties of solid, liquid, and gas. So can you all write these answers?
Yes, sir.
Yes or no?
Yes, sir.
Not getting voice. Yes or no? That's great. Okay, you can go back to your seat. Clap for her, guys. Okay. Now, again, we have a question. I'm going to give you the question. You're going to take 1 minute time to think and just you're going to raise your hand, okay? No cheating. Gases can be liquefied under which conditions? If suppose you want to liquefy a gas, what you are going to do? Are you going to increase the temperature or decrease the temperature? Are you going to increase the pressure or decrease the pressure? Okay. Let's talk about the temperature. If you want to convert a gas into liquid, the temperature should be increased or decreased. Who is going to tell me? Decrease, down, or up? Decrease, everyone? Okay, that's great. And what about the pressure? Should we increase the pressure or should we decrease the pressure? Okay, how many of you feels that, okay, pressure should be increased? How many of you feels this? That pressure should be increased? Raise your hand. And how many of you feels that pressure should be decreased? No one? In both the answers, you're not raising your hand? What happened? Okay, I'm going to ask you again. We are going to convert a gas into liquid, okay? What we're going to do, we're going to convert a gas into liquid. So for that, we need to decrease the temperature, right? And what about the pressure? Should I apply more pressure on the gas to convert it into a liquid, or should I release the pressure? Think about it. Think. Yes, see, we have these gases molecules, yes or no? Now, if you need to convert it into liquid, the distance should be, the spaces between the molecules should be reduced, yes or no?
Yes,
So to do that, will you apply the pressure or not?
sir.
So do you have to increase the pressure or do you have to decrease the pressure? Then why you were not telling earlier? Forgotten everyone. Chalo. Now understood now? What we have to do with the pressure, should we increase or decrease? Increase. That's great. So if you're going to reduce the temperature, if you're going to increase the pressure, you can convert a gas into liquid. Yes or no?
Yes, sir.
That's great. Now, let's come to the another topic, which is diffusion. Should we? Yes? So the basic thing we discussed about the matter, we discussed about the different states of matter, we discussed about their properties, and just in a brief, we were going to also talk about the plasma and Bose-Einstein. Plasma was what? Plasma was? Yes. And what about the Bose-Einstein? It is what? It is made in laboratory. Yes or no?
Yes, sir.
Yes. And any example of plasma state? Any example of plasma state? Anyone? Anyone?
Lightning.
Yes, lightning. Yes, that's great. So everyone, what's the example of plasma state? Lightning. And if I talk about the bulbs which you are using, is it also an example of plasma state? Yes. Clear? Seems that you all have not studied in during the holidays. Yes or no? You all have not revised. That's why you are unable to answer. Okay, promise me everyone that today you are going to revise these sessions and you are going to solve all the pending questions and everything. And if in case you are going to have any doubts, you're going to ask me in the next session, right? Now the holidays are over, and if not, I'll just reduce your Diwali holidays. Do you want me to do that? Okay, I'm going to take the class on Diwali. Who is going to come? Anyone? No one? Okay. So for that, you should revise. Otherwise, I'll tell your teachers not to give holidays for the Diwali. Okay? Yeah. Chalo. Should we move forward? Okay, who is going to tell me the definition of diffusion? Fast. Definition of diffusion. Fast.
Concentration to lower concentration.
Yes, exactly. So diffusion is what? It is the movement of a liquid or a gaseous substance from its higher concentration towards the lower concentration. Yes or no?
Yes.
Yes. Now, one more thing. Do solid get diffused?
Yes, sir.
Yes. Who said yes? Okay. Let's suppose this is a box. Are you able to see this box? Now, if suppose I'm going to take this box and I'm going to stand it like for 2 hours, 3 hours, will this box will move towards the lower concentration? No. So diffusion of solids do not take place. Yes or no? Yes, clear?
Yes, sir.
Okay. Any examples of diffusion, guys? Any examples? I need 5 examples from school 1, school 2. Both of you. Fast. I'm going to check which school is going to give me the quickest 5 examples. Not like this. Not like this. One by one. Just raise your hand once. Just raise your hand. School 1, school 2. Yes, I have a boy from school 1. What's your name? What's your name?
School 2, sir.
Oh, school 2, school 2. Yes, so sorry. What's your name?
My name is Sai, sir.
Okay. So what examples you're going to give for a diffusion? Yes? What you're saying, I'm unable to understand. Can you please repeat it once again? Please do it once again. I'm unable to hear that. Movement of? Okay. Let's. Can you give mic to anyone else? Can you give it? What he's saying? Can you just repeat once again, guys? Okay. Actually, the voice is echoing, so I'm unable to understand what you are saying. But I believe that you're giving me the correct answer. I believe. Yes. Anyone who is able to understand will help. Can you help me? What he's saying? Okay. Clap for him, guys, everyone. Okay. Any other examples anyone wants to give? School 1, yes, please come forward. So we have one example from school 2. We have one example from school 1 as well. Yes.
Leaking of gas, sir.
Breaking of gas.
Leaking, sir. Leaked gas.
Okay, leaking of gas. Exactly. That's great. Clap for her, guys.
Sir,
Any? Yeah.
sir.
What?
Perfume, sir.
Perfume, exactly. So we have 3 examples. We have 2 examples from school 1. Any other examples you want to give?
Deodorant, sir.
Deodorant and perfume, kind of same thing. I'm not going to consider that.
Cigarette smoke, sir.
Which one?
Cigarette smoke.
Cigarette smoke. Okay. Any other ones? Yes, from school 1 we have, school 2 we have. Yes.
Sir.
School 2, you can speak. School 2, am I audible? School 1 is helping, huh? School 2, am I audible? Okay. The boy who's standing in school 2, can you please say what's your example?
Agarbatti.
Which one? Agarbatti. Yeah, see, now I understood. Chalo, that's great. That's a good example. Any other example?
Mosquito repellent, sir.
Mosquito repellent. How? That electrical one?
No, sir.
That cream one?
We diffuse the
So that is the electrical one, right? That we plug. Yeah, that we plug into our switchboard and it vaporizes and spreads all over the room. Yes or no? Yes. So we have plenty of examples of diffusions. Yes or no? Should we revise the main 5 examples of diffusions? Yes. Should I tell you the other examples of diffusions? Okay, chalo, that's good. Whoever answered my questions, I'm just going to clap for them. That's great. I believe that my clapping sound will not be, you will not be able to hear, but yeah, I'm clapping. See. Okay, chalo. Let's go with the examples of diffusions. Okay, see, diffusion of gases. That one you said, a smell of deodorant. Yes or no? Burning of incense sticks. That agarbatti one. And diffusion of liquids. When we mix milk and water, diffusion is happening. Yes or no?
Yes, sir.
Now, diffusion of solid particles in liquids. Now see, we discussed that diffusion of solids cannot happen, but diffusion, the solid particles can diffuse in liquids. Yes or no?
Yes, sir.
Just like we did one example, that Ujala, do you know Ujala?
Yes, sir.
When we used to wash our white clothes. And when I was child, what I used to do is that whenever like on Saturdays, we have that white uniform. And I love to do, I love to play with that blue color Ujala. So what my mom used to do is that whenever she used to go wash my clothes, I just check whether she's not around or not. I just used to go to the bathroom, and instead of like putting 2 to 3 drops, I used to put this much amount of Ujala. And what happens that my whole white color dress turns into blue color. And when I go to school, my teacher scolds me that what you have done with your dresses. So why this happens? Because of the diffusions. If I'm going to add more particles of that Ujala, more diffusion will take place, right? It is going to diffuse more into the liquid. Yes or no? Yes. In the same way, instead of Ujala, we have a pink color substance, which is known as potassium permanganate. It's a chemical substance, right? And this pink color substance is what? It is in solid state. Yes or no? Potassium permanganate crystals. Remember, we discussed this in the classes. Yes. So this is a solid, but when you put this into a liquid, it diffuses. Yes or no? The whole liquid slowly turns into pink in color. Clear?
Yes, sir.
Okay. And can 2 gases be diffused? Can 2 gases be diffused? Yes, obviously, gases are diffused. Gases, like diffusion of gases takes place. So 2 gases can also diffuse. Yes or no? Let's suppose, okay, I'm going to give you an example. Let us suppose that this is your room, and in your room, here is a corner A and this is the corner B. And corner A, let's suppose you have HCl gas, and in corner B, let's suppose you have NH3 gas. Okay. So what will happen? What will happen? Will it move towards each other? Yes? Yes or no? Yes. So the diffusion of 2 gases are happening or not? Yes. Remember? Is it clear?
Yes, sir.
So, how many of you are going to remember all these examples? How many of you are going to remember all these examples? No one. Okay, only one person. Yes, now I can see the hands. Okay. In the next session also, I'm going to ask you some of the questions regarding this chapter and I'm going to check whether you have revised or not. Will that be okay? Okay, that's great. So should I move forward? Should we go with the questions now? Didn't we left anything? Is it fine? Should we move forward? Which one? Temperature. Did we discuss rate of diffusion? This is left now. Okay, see. What about the rate of diffusion? Now, why does diffusion takes place? Anyone? If I'm going to ask you that why diffusion takes place, then what will be your answer? Number one is that due to concentration gradient. Yes or no? Yes, if suppose there is no concentration gradient, will diffusion takes place? Think about it. If suppose the quantity of both the particles are same in different places, will diffusion be taking place? Let's suppose we have A and we have B, and here also we have 100 ml of water, and in B also we have 100 ml of water. Will diffusion takes place? Yes or no? If in both cases we have equal amount of water, will diffusion takes place? No, right? So for diffusion to take place, let's suppose I'm going to have, let's take another example. Let's suppose we have A and B container, and in A we have 50 ml of water, and in B we have 100 ml of water. Now diffusion will take place or not? Yes. So from where the water is going to move from which side to which side, who is going to tell me? From B to A or A to B? B to A, right? So what is the necessity? What is the necessary thing to diffusion for to happen? One is the concentration gradient. Yes or no? Yes, exactly. And now we are going to talk about the rate of diffusion. Now, one question, I'm going to give you one question. We have, let's suppose we have solid, we have liquid, and we have gas. Okay. Now, diffusion, my question is, diffusion is fastest in solid, liquid, or gas? Which state? Sure. Is it everyone? Sure. Yes. Okay. Now, who is going to give me the reason for this? Why diffusion is fastest in gases? Less molecules or less spaces? Yes, exactly. And if suppose in exams, same question arises, like it says, which among the following, which is having, in which the diffusion is least. So what will be your answer? Solid. And what will be the reason? Because solid has less intermolecular space. Exactly. So you are able to understand the rate of diffusion, yes or no? Clear. That's great. Now, again, we have a question time. So should we solve the questions? Yes or no?
Yes, sir.
I'm not feeling that energy. Yes or no?
Yes, sir.
Now that's called the energy. Now, okay. Okay. So here is the question. The question says that what happens when ink is dropped in the water, and you're going to raise your hand. You're not going to prompt your answers. School 1, school 2, read the questions and raise your hand. Who said the answer? Who said the answer? Everyone thinks B is the correct answer. Everyone?
Yes, sir.
Okay, yes. So B is the correct answer. This was a easy peasy question, yes or no? Yes. So all the questions related to the topics are very easy when you are able to understand the topics. Yes or no? When you don't know nothing about the topic, every question seems very difficult. But when you revise the chapters, when you know practice a lot, the hard questions also seems very easy. Yes or no? Do you believe in this? That's great. Now, so the answer is it evenly spreads in all directions. That's okay. Now, let's move on. Any doubts in diffusion, guys? Any doubts? Do you have any kinds of doubt in diffusion now? Okay. Now, let's talk about the interconversions. Now, we all know that you can convert solid state into liquid state. Yes or no? And you can convert liquid state into gaseous state. Yes or no? And everything is having what? It is having a name. If you're going to convert solid, let's suppose this is the solid particle. If you're going to convert this solid into liquid, that term will be known as melting. Yes or no?
Yes, sir.
And if you do the vice versa, that means if you just do the opposite thing, like if you're going to convert this liquid to the solid, then it will be what? It will be called as
Freezing.
freezing. Understood?
Sir.
Yes. And if you want to convert this liquid to the gases, then what will be the process called? And if you want to do the opposite thing, like you want to convert the liquid, sorry, you want to convert the gases into liquid, then what will be the name of the process?
Condensation.
Condensation. Exactly. And you don't want to, keep liquid in the middle. You just want to, okay, I'm a magician, I'm going to convert the solid directly into gases. Then what will be the name of the process? Sublimation. And if you want to do the opposite thing, like you want to convert the gases, like we have some children, like suppose when a magician is performing the magic, there are some students which are going to check the magicians. They are going to say, okay, you have converted solid into gas. Now convert you just convert gas into solid. So then if the magician is going to convert gases into solid, then what will be that process called? Deposition. Exactly. So basically, to become a magician, you need to have a scientific knowledge. Yes or no? Yes, magicians applies lots and lots of chemistry, lots and lots of physics in their magic. Do you know that? Yes? Or do you feel that magicians are for real? Or they do just what? They just understand, they just, have the knowledge of some of the scientific experiments, and using those scientific experiments, they shows the magic to everyone. Yes or no? Anyone who wants to become a magician here? Anyone? No, no one. No one. Okay. Anyone who do some kind of magics? Anyone? The magic tricks or something like that? Anyone? No one. Okay, that's great. So we don't have a magician in these schools. That's great. Should we move forward? Any doubts in any of the terms?
No, sir.
Clear?
Yes, sir.
Okay. Now, question. So just read the questions. I'm going to read the question for you and you have to answer this. Okay. The question says that which one of the following sets of phenomena would increase on rising the temperature? Now, if you're going to rise the temperature, if you're going to increase the temperature, which one of the following will increase? The question is asking that. Okay, you have the options below. Yes, think about it. If you're going to increase the temperature, diffusion will increase or not? If you're going to increase the temperature, evaporation will increase or not? If you're going to increase the temperature, gases will be compressed or not? Think about it. Which will be the correct option? A,
C.
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 Okay, evaporation, solubility, diffusion, and compression of gas. Can you just check the option C once again, guys? Whoever is telling option C is the correct answer. Just check it once. A. Okay, how many of you feel that A is the correct answer? Okay. How many of you feel that B is the correct answer? Yeah, school 2, no one. No one feels that B is the correct answer. School 2. B and C. Okay, chalo. So yes, the correct answer here is the B. Now, why B is the correct answer? C was also the correct answer, but here in C we have one option which is compression of gas. So that's why this option was wrong. Yes or no? Otherwise, all the things increases, like if evaporation increases, solubility increases, diffusion increases, right? When we increase the temperature, but the gases expand, they do not compress while we increase the temperature. Yes or no? Clear to everyone? Any doubts anywhere? Okay, that's great. Now, okay, we have some terms like evaporation, freezing, right? Vaporization, everything, these terms are clear to everyone. Do you have any kinds of doubt in these terminologies? Anyone? No doubts? Okay, that's good. Now let's get back to the heat one. We have two kinds of heat. We discussed heat in these classes, yes or no? Okay, who is going to tell me about latent heat? Who is going to tell me about the latent heat? What was latent heat? The heat which is used to change the, yes, I got some answer. Can you please stand up and say? Whoever said that, can you please stand up and say? I think so, from school 1 or school 2? School 1 or school 2? School 2, do you want to say something? Yes, please come. You are holding a notebook, I'm saying. Is this a cheating? Keep your notebook aside and then answer the question. Okay. Now you're reading there. I can see there. I can see you. I can see you. Yes. Okay. Now, school 2, the girl sitting in the second row. Please answer my question. The girl sitting in the second row. Can you just stand up? Yes. Please stand up. Please come in front. Yeah. Can you answer this question, that what is latent heat? Can you answer this? Yes. Can you answer what is latent heat? Okay. We will help you. We will help you in the answering. Okay. So I'm going to help you in the writing the definition of the latent heat. Okay. Everyone, along with this girl, is going to repeat after me. Okay. Ready? So let's see. Heat which is used to change, yes, change the state or phase. Yes or no? So just repeat this statement, everyone. I want to hear it from everyone, along with the girl who is standing in school. To school, first of all, the girl will say, and everyone will repeat after her. Okay, ready, everyone? Okay, let's see. Yes. Yes, heat. Everyone, school 1 also. Yes. And what about the specific heat? Heat which is used to increase the temperature. Yes, that's very good. Clap for her, guys. And don't talk between the classes, okay? Chalo. Now, specific heat, do I need to write a definition? Okay. So should I write in a short manner that it is used to increase the temperature, yes or no?
Yes.
It is used to increase the temperature. Now, since specific heat will be dealt in the next chapter, that is heat, but we have studied about the latent heat, yes or no?
Yes, sir.
So we have lots of latent heat name, right? We have latent heat of vaporization. We have latent heat of, freezing. Yes or no?
Yes, sir.
We had, yes. So if I talk about the latent heat of vaporization, so where you are going to use this latent heat of vaporization? In which process? In melting, in boiling, in condensation, or in freezing? Yes, anyone? You have to, latent heat of vaporization means what? You have to make the vapors. And when you are able to make the vapors, yes, girl, one, please, everyone, please pay attention here. I'm sitting in front of you. Can you see me, everyone?
Yes, sir.
Yeah, so don't look back. Chal. Now, if I talk about the latent heat of vaporization, that means what? That means we need to convert a liquid into vapor, yes or no?
Yes,
And during which process this happens? In boiling or condensation?
Boiling.
Boiling, exactly. So when do you need to provide this latent heat of vaporization? When you are going to boil something, yes or no? Yes? Okay. And if, what was the another one? Like latent heat of vaporization was there. And what was the another one? What was the name of the another type of latent heat? Anyone? Do you remember? Anyone? Fusion, exactly. We have latent heat of fusion. So let me write this again. Latent heat of fusion. Okay. Now, where you are going to use this latent heat of fusion? Yes. Yes, during which process? During melting, during freezing, during boiling or condensation?
Boiling.
Are you sure you are going to use this during the boiling? Anyone? Anyone? Are you sure you want, do you want to change the answer? Yes, we are going to use in melting, not freezing. When you are going to melt ice, at that time you're going to give this latent heat of fusion, okay? Clear to everyone?
Yes, sir.
That's great. That's great. So now you're able to understand in which process you're going to give what kind of latent heat, yes or no? Okay. Now let's suppose that if I want to transfer heat towards you, if I want to transfer the heat towards you, can I do it in 3 ways, yes or no? We discussed this, right? In the session, we can transfer the heat with the help of conduction. Yes, we can transfer the heat with the help of convection, and we can transfer the heat with the help of the radiation. Yes or no? Now, what are these things? We just discussed the names of these things in this chapter. We are going to discuss the detailed version in the coming chapters. Okay. So by these 3 ways, the heat can be transferred. Just remember right now. Clear? Any doubts still here to anyone? That's great. Now we have the question times and we have lots and lots of questions. So are you all ready to solve these questions?
Yes, sir.
Okay. But before that, I'm going to give you 2 minutes time. Just go through your notebooks. If you have any kinds of doubt, any questions regarding any topics, please ask me. Just go through your notebooks, just check it. If there is any doubts in any topics, if there is doubt in any question, anything, please let me. Everyone, please check it. Anyone? Any doubts? Just let me know. Yes, first one. Do you have a doubt? School one, first girls. Having any doubts? You can just ask me rather than discussing among you. You can just raise your hand and just ask the doubts from me. Okay. How many of you are just reviewing your copy for the first time? Is there anyone who didn't revise and just revising your notebook right now? Is there anyone, student? Okay, that's great. No doubts? School one, first three girls, no doubts? Second three girls, any doubts?
No, sir.
Okay. First benches, boys, school one, school two, any doubts? All clear?
Yes, sir.
Okay, that's great. That's very good. So should I go with the questions? Everyone? Should I start with the questions?
Yes, sir.
Yes. The last bencher boys from yes. Okay. The last bencher, the boys from the last benches, school one, school two, any doubts? Sure?
Yes, sir.
Okay, that's great. So should I ask the question individually now?
Yes, sir.
Okay. Ready, everyone?
Yes,
Everyone, close your notebooks. Close your notebooks. Yes. Now, the last boy sitting in the school one, please stand up. The last boy sitting in the school one, please stand up. Okay. You can come forward. Come forward. That's great. What's your name?
Kamaluddin sir.
That's great. So should I give you the question?
Sir.
Okay. Now, the question is, oh, it's an easy peasy question, right? When someone opens a packet of room freshener in one corner of a room, its smells spread in the whole room quickly. This phenomena is known as boiling, just one second, evaporation, osmosis, or diffusion. According to you, what will be the answer? I asked from him, everyone told the answer. Okay, so yes, exactly. So everyone is satisfied with his answer?
Yes, sir.
That's great. School 2, are you satisfied with his answer?
Yes, sir.
Okay. Should we allow him to go back to his seat? No? No or yes? Should I tell him to go back to his seat? No. Who said no? Who wants him to be standing the whole classes? Huh? Okay. Chalo, clap for him. Okay, you can go back to your place now. You can go back to your place. Okay, that's great. So anyone who is having any doubts in this particular question? Okay, should I give you the next question?
Yes, sir.
Okay. The next question we have is, if the amount of heat given for a phase change of a substance is 600 kilocalorie, you have to calculate the latent heat of the amount. You have to calculate the latent heat if the amount of the material is 10 kg. Now, do you remember the formula? Do you remember the formula to calculate latent heat? Q equals to ml. Do you remember that?
Yes, sir.
Okay. Who is going to try this question? Who is going to try this question? Everyone, just start solving. I will check whether who is going to get the answer. Now, to solve, you have to open your notebooks now. Open your notebook and try solving. It's very easy. Check which is given in the question, what value is given in the question, and what value you have to find. It's just a simple multiplication and division. That's all. We have done these questions in the classes. Yes or no? Yes or no?
Yes, sir.
Yes. So you all have forgotten, right?
Yes,
I am. Let's see who is going to give me the answer. Okay, I'm not going to give you much time, just 2 to 3 minutes. That's enough. Okay? And your timing is started now. Like I am keeping an eye on the watch.
16 calories. 60
Six,
calories.
16.
60 calories by kg, sir.
60 kg?
60 calories by 1 kg.
Okay, that's great. Okay, one answer we got 60. Any other answer? Any other answers? Any other answer? Okay, what was his name who answered the question? What was his name? What? Sidhu. Okay, that's great. Any other answers? School 2, you are lagging behind. School 2, find out the answer fast. School 2, need the answer. Give me the answer.
60, sir.
60.
Yes, sir.
Oh, okay. So both the schools is having 60 answer. That means 60 will be the correct answer. Yes or no? Should I solve the question for you? Now, why you don't say no, sir? We will solve by our own. Always you say yes, sir. You solve it. Okay, I'm going to solve this question for now. But from the next time, I want everyone to solve this question by their own. Yes or no?
Yes,
Okay, chalo. So the heat is given 600 kilocalorie. Yes or no?
sir.
The mass is given as 10 kg. Yes or no?
Yes, sir.
You have to find this L, and to find this L, you just need to simply divide 600 upon 10 and you're going to get 60. Yes or no?
Yes, sir.
That's a very simple question. Understood?
Yes, sir.
Clear to everyone?
Yes, sir.
That's great. That's great. So should we move forward with the next question?
Yes, sir.
Ready, everyone?
Yes, sir.
Okay, I'm going to choose one person. From school 2, can you just move the camera a little bit towards the left? Yes. Now I can see the boys. This boy who is sitting just behind the wall. What's his name? Hardik. What you said? What's your name? Okay, that's great. Now, should I give you the question? You take the mic. I'm going to ask you the question. Should I give you the question? Okay. The question is, why is it easier to dry clothes on a hot sunny day? This is an interesting question. Why is it easier to dry clothes on a hot sunny day? Should I give you a hint? Yes or no? Should I give you the hint? Yes, school 1, school 2. Okay, you can discuss with your friends and you can answer me this question. I'm giving you time. I'm giving you 30 seconds time. You can discuss with your friends and then answer me. Yes, exactly. Water evaporation. Why? Because during the sunny day, the temperature will be more, right? Yes or no? The sun will be dancing like this. During the sunny day, temperature will be more. And if temperature will be more, what will happen? Evaporation will be more. Yes or no?
Yes,
And in the same way, if suppose that day is cool, there is no sun, that rate of evaporation will be what? It will be less or more?
sir.
Exactly. So do you understand the concept behind these questions?
Yes,
Okay, that's great. Clap for them, guys. Okay. That's great. Now you can just go to your place. Okay. Now, next question. Ready, everyone?
sir.
Okay. Rate of diffusion depends on. Oh, I have to choose the student. The girl who is sitting in the third bench, school 1, third bench, middle girl. Third bench, middle girl. Rate of diffusion. Rate of diffusion depends on. Yes. Yes. Rate of diffusion depends on. What is your name? Sheetal. What? Abhya. Okay. I can't pronounce that word. Okay. So, okay. Can you just tell me once again your name? Abhay Nishri. No, again, okay. Chalo, I'm very bad at pronouncing your names. So sorry for that. Okay, let's get back to the question. What is, rate of diffusion depends on. We discussed this thing. Yes. See towards the camera. Rate of diffusion depends on. The term starts from C. I am going to give you a hint. The term starts from C. Yes, concentration gradient. That's very good. Clap for her, guys. If suppose the concentration gradient, like suppose they just let's give an example. If suppose we have A and we have B. Okay. Oh, why I'm writing B here? Just give me 1 second. Let's suppose we have A, let's suppose we have B. Okay. And in A we have 50 ml water and in B you have 100 ml water. Okay. And there is second case where you have 70 ml of water in A and 100 ml of water in B. Okay. So in which case the diffusion will be faster, in case 1 or in case 2? 1, right? Why? Because the difference is more. Yes or no?
Yes.
Understood, everyone? That's great. Clap for her, guys. Okay, that's great. You can get back to your seat now. Okay. So we have covered the chapters very well, and I believe that all the topics, all the concepts are clear to you. Yes or no? Now, what you're going to do is that you're going to go home. After going home, you have your textbooks with you. Yes or no? The SCERT book. Yes or no? Okay. The books which you follow to study. Yes or no? Yes. So you are going to do what? You're going to take your pencil in your hand and you're going to go to the home and you're going to write or underline the important lines in your book, underline the important terms. And in case you find that you're going to have any kinds of doubt, like suppose in your book there is a particular kind of lines or a statement which you are unable to understand, just underline it, and in the next class of the PS, just ask me those concepts. Okay? Okay, everyone? So what you have to do is that just today or try to finish off everything of this chapter. Like we don't want to see, we don't want to read this chapter again. We just need to revise this chapter, finish it like this. Okay, everyone? Okay, so from the next class of the PS, we will be starting with a very new chapter that will be the heat. Clear? Okay, so till then, bye-bye, everyone. I hope you enjoyed the classes. Yes or no? Yes. That's great. So have a good day, everyone, and do revise the sessions. Worksheets also, right? Okay. Chalo, bye-bye. Bye.